Next, I will show how to apply the two means z procedure to test a statistical claim about two population means when population standard deviations are known. Consider the following example. A group of researchers wants to know whether men's life expectancy is shorter than women's life expectancy in the US in 2018. Historically, the standard deviation of men's life expectancy is known to be 15.8 years, and of women's life expectancy is 13.4 years. The average life expectancy among 68 men in the sample was found to be 76.3 years, and the average life expectancy among 54 women in the sample was found to be 81.4 years. At 10% significance level, test the claim that men had a shorter life expectancy than women in the US in 2018. First, let's note that the sample means are 76.3 years and 81.4 years for men and women respectively. The sample sizes are 68 for men and 54 for women. And the population standard deviations are given. Sigma 1 is 15.8 years and sigma 2 is 13.4 years. Now let's identify the statistical claim that needs to be tested. The claim is that the man's life expectancy is shorter than women's, so we can symbolically express the claim as mu1 is less than mu2, or equivalently as mu1 minus mu2 is less than 0. Since the claim is about the population means and the population standard deviations are given, we'll use the two means z procedure. Before we begin the two means z procedure, let's check if all necessary assumptions are satisfied. The samples must be assumed simple random and independent. If not, then the results of the test are invalid. The central limit theorem must be applicable. In other words, the populations must be normal or the samples must be greater than 30. The population standard deviations must be given. We will use the following template to perform the hypothesis testing. In step 1, we will set up the hypothesis. In step 2, we will identify the significance level. In step 3, we will find the test statistic using the formula. In step 4, we will perform either the critical value approach or p-value approach to test the claim. In step 5, we will draw the conclusion, and finally in step 6, we will interpret the results. Since our claim mu1 minus mu2 is less than 0 is in the form of an inequality, we're going to set it up as an alternative hypothesis. Therefore, the null hypothesis, which is always in the form of an equation, must be mu1 minus mu2 equals 0. So the test is left tail. Step 1 is complete. The significance level can always be found in the statement of the problem. In our case, it is 10%. Step 2 is complete. The test statistic can be computed using the formula. In our case, the test statistic z0 is equal to negative 1.928. Step 3 is complete. Next, we will test the hypothesis using two different approaches, the critical value and the p-value. In critical value approach, we construct the rejection region. In this approach, we need to know the significance level alpha and the type of the test. We draw the rejection region under the standard normal probability density curve according to the type of the test. So left tail test will have the rejection region in the left tail. The region must have the area equal to the significance level 10%. The right boundary of the region is the critical value, negative z 0.10, which is equal to negative 1.282. So the entire region can be described as all the values to the left of negative 1.282. In p-value approach, we compute the p-value. In this approach, we need to know the test statistic and the type of the test. We find the p-value using the standard normal probability density curve according to the type of the test. So in a left-tailed test, the p-value is the area to the left of the test statistic. Symbolically, it can be expressed as the probability of z being less than -1.928, which is equal to 0.027. Next, we are going to decide whether to reject or not reject the null hypothesis. In the critical value approach, we must check whether the test statistic is in the rejection region or not. Our test statistic is -1.928, and it is to the left of the critical value, -1.282. Thus, it is in the rejection region. In the p-value approach, we must check whether the p-value is less than the significance level or not. Our p-value is 0.027, and it is less than alpha. Both tests suggest that we do reject the null hypothesis in favor of the alternative. Next, we are going to interpret the results. Interpretation. Under 10% significance level, we have sufficient evidence to suggest that men's life expectancy was less than women's life expectancy in the US in 2018. I just showed how to apply the two means z procedure to test a statistical claim about two population means when the population standard deviations are known.